So today we're going to talk a bit about SonarQube, and it's more or less like a whirlwind tour through SonarQube. So lots of features will pop up, some more related to others than some others. So it's more or less spreading the whole spectrum of what SonarQube is doing. So this is a bit of the agenda for today. Questions are at the end, but please feel free to interrupt me if you have any questions, and I'll try and answer them immediately. That's just as easy. But first, why should we do quality software or quality whatever? I mean, the Egyptians knew it quite well. If you build something of good quality, you can make money of it for a long period of time. I mean, the pyramids, they're still there and they still make lots of money without them having to do a lot on it. I mean, they even let the nose fall off, and it's even a bigger attraction now. So if you build quality in, it can last for a long time, but sometimes the quality is not good enough, and you have to do a bit of patching and fixing, and then you can again get money for it for the next couple of years. And I don't know how it's here in Sweden, but in Holland, we sometimes have projects that miserably fail, not only software projects. For instance, these trains, they rode for, I think, 39 days, and then they fell out of each other, and everything broke loose, and they stopped using them. So that's really shitty quality, and that will cost you a lot of money because they had more or less need to throw away these trains and buy other trains. So that's, I think, the same in software. I mean, in software, we all have bugs. I mean, Microsoft did a calculation how much bugs they have. Of course, I assume we Java developers have a lot less defects than these guys from Microsoft. But still, I mean, NASA Spirit rover, Google search engine, everybody makes mistakes, but the point here is find them as quickly as possible. I mean, you know there are mistakes, so just detect them, and then you can simply move on after you have fixed them. Another common misconception when using tools like SonarQube to check your code quality is that, oh, I have to do this for my manager because he wants to see a green ball. But why that mentality? I mean, if you're a software developer, you want to deliver good quality software, isn't it? I mean, code quality is a part of that. So to improve yourself and make sure that you deliver good quality software that will function properly in production, these tools can help you. It's not a punishment, it's a tool to aid you in becoming better. About SonarQube, it's a really active platform since 2006. They have numerous plugins, and name it and you can find it in there. And these were some statistics from 2013, not because I was lazy and didn't want to look up the statistics of 2015, but they didn't release those statistics last year. So this is just to give you an impression in how active it is. So they have like 5 major releases every year. It's a really active open source project. And the image depicts it already. It's quite lonely at the top. I don't know any open source competition for SonarQube. They're really advanced in doing all kinds of software detection algorithms. And how does it work then, more or less? You can simply throw some code at it, and it doesn't really matter if it is Java code or C# or some other language. And they have different scanners to analyze that code. That's then processed to SonarQube. Data stored in a database. You can more or less freely choose which database you want to use and just hook it up to your SonarQube instance. And if you just want to use SonarQube, you don't just to test it, then you don't need to install a database. You could use the in-memory database, but that's not suitable for production, so as soon as you start using it seriously, you should drop that one. A bit about the basic features to get up started, but the question first, who of you is using SonarQube already? Okay, so quite some hands. And who of you are using like the version that looks like this? Okay, fewer hands. So I'll go quickly through this. The point is they, in the last releases, more or less refactored everything. They threw away some features, changed the GUI completely. When I redid these slides for JFocus, I was like, okay, I update it and just take new screenshots and then I'm done with the new version of SonarQube. But it actually took quite a lot of time because they completely changed how it worked, more or less. So what we have here is the main screen. If you go to SonarQube, these are the different projects that you analyze. And when you click on them, or on one of them, you get an overview. An overview is then showing some things like technical depth, coverage, duplications, and structure. And something which is new to be noted here is the leak period. I will talk about that in a moment. And from that page, you can drill down to the different pages, like technical depth, like coverage, like code duplication, like structure. So here you can even see that in the same project, we're using multiple languages. So it's not only a Java project. My JavaScript files, my XML files, my CSS files, my HTML files, they're all being analyzed by SonarQube in the same project. I mean, if you used SonarQube before, it was also possible, but you had to create like a separate project for every language. It was a bit of a hassle, and now you can just do it within one project. You can see complexity. But what about the leak period? The leak period is something that's quite interesting, especially if you have like large software systems which are maybe not as good as you want to, and there are lots of SonarQube violations. What do you do then with when you add new code? I mean, you cannot just fix all the issues and then start adding code. You probably have to add some business features already. So what you can do is define like leak periods, and a leak period is more or less a period where you compare to. So in this case, the leak period is previous version, so then the current version is compared to the previous version, and SonarQube will look if there are any issues that were added in the new version. So that's something that's quite helpful. Then you can see, okay, I just submitted some code, and apparently I introduced these new issues, so I have to fix at least these issues. And another nice thing is that you can define other periods. For instance, here I say 14. 14 means 14 days. For instance, if you do Scrum and you have a sprint of 14 days, with this you can then see, it's shown here, what the difference is in code quality in the last 14 days. So you can see if in this sprint the code quality improved or if it got even worse. So that's a really nice way to make sure that at least the new code that you introduce within your project is of a good quality. The dashboards that we just saw, you can create extra dashboards because everything is more or less a widget, a small placeholder with some functionality behind it. And you can add multiple dashboards, for instance, one for your manager with all kinds of flashy stuff, and one for yourself with really the code issues that you want to see. You can drag and drop that. So these are just some of the widgets you can choose from. For instance, there are widgets for duplications. You see one here. And you can simply add it, and then you can rearrange it here, or you can even change the layout here. So you can completely customize your own dashboard, which is really helpful, I think, so that you can concentrate on the issues that matter for you. Maybe duplications, you're not really interested in it, then you can just leave that away. How does that work? How do we then check that code? SonarQube works with profiles. So for instance, they have a Java profile, and in that Java profile there is a set of rules. And rules before were rules from Checkstyle, Findbugs, and PMD, so checks if something can be null or if the formatting is wrong, stuff like that. And nowadays they have more or less re-implemented all those rules from Checkstyle, Findbugs, and PMD in their own rule engine. The big advantage is that they only need to parse the code base once instead of parsing the code base for every tool that they use. And the other advantage is when the new Java version came out, the guys from SonarQube had to upgrade Checkstyle because the guys from Checkstyle were too slow implementing Java 8. So now they're a bit less dependent of it. And then a profile can be coupled to one of more projects. So your own project, and you can have multiple of them depending on how your setup for your application is done. This is how then profiles look. So we have profile has a set of active rules in different criteria. You could even attach projects to it, or you could say, okay, this profile is my default profile, so all projects should use this profile. And you can even inherit it. So you could create like a base set of rules within your profile, like your minimal rules that you want to have. And you can make like an extra set of rules for the projects that want to get really good quality and want to have a lot of extra checks. That's all possible. rules look like this, and you can see here there are like really a lot of rules. You could use the default rule set that SonarQube is already providing, or you could change some rules, activate it, deactivate it, change the severity according to your own needs. So you can do whatever you want with it. And then when we have those rules, we have those checks, then it would be nice if we are alerted immediately if something is wrong. And what's wrong? For instance, what we want is the coverage on the new code since the previous version shouldn't be less than 80%. So all the new code that's being added to the project, we want to make sure the code is at least 80%. And if that's not the case, then we will get a big warning on our screen. So that's really easy to see. So we can do this on time difference, but we can also say like duplicated lines, we only want 100 maximum. So not 100 added in the last version, but in total we do not want more than 100 of them. And what you then can do is you can add notifications to it. So within SonarQube you can say, okay, if there are new issues in my project, send me an email. So in case I forget to look at the SonarQube dashboard, I at least get a notification that I broke something. And then I can fix it myself. Analyzing data. So some violations or issues that SonarQube detects, they are really true or false. I mean, if a unit test fails, it's a failing unit test. You cannot really discuss about it. But what about complexity per class, or complexity per file, or per method? What number is high and what number is low? I mean, here we see for a project like complexity of 11 per file, and here it's 3 per file. Is 3 low, or is 11 high, or are they both low? No idea. But if you use compare, you can compare a set of different projects with each other and then see, okay, so most projects have this value, so probably this is a good value to have for our project to aim at as well. So then you can get a bit of a common understanding of how these values are in different projects. For instance, here I compared 2 versions of SonarQube and a project of my own, and then you can compare almost anything. So you can add more projects. These metrics you can add at the top, so you can check almost every value that SonarQube is measuring and then compare it with the other projects. So that can be quite helpful. Measures. Measures is a bit like Googling within SonarQube. So you can specify some criteria, and then SonarQube will look within your database which files, for instance, match that criteria. So in this case, we search for files. You could also search for projects. But we look for files with a number of duplicated lines is more than 5. And then we get the results back. So this is, again, a way, for instance, to see if certain portions of your code are really bad. Or if you see like, oh, okay, I see that some projects have like 10 duplicated lines. How many projects have more than 10 duplicated lines? Therefore, you could use the measures. Really easy. And measures and compare it looks really nice, but maybe also have a manager. Most of us, unfortunately, have. And they tend not to be good with numbers. They want flashy graphs, charts, and Excel sheets and stuff like that. So they also have included a bubble chart. So what this more or less does is, this is one of my projects. So if you hover over it, you can see which project it is. And I think the size depicts the... the lines of code is depicted on this axis, and the complexity is depicted on this axis. So then you can see how different projects compare to each other, but then in a really visual way. And you have another one, that's this one. This is even more advanced. So you can specify the different axes, but you can also specify the color and the size of the round shape. And then you can play it. So this is like a function in time. So you can play how the program evolved over time. So when I did this on a project, I could notice that, for instance, the lines of code went up first, and after that, the number of unit tests went up. So that's typically not test-driven development. And you could see that easily with this chart. And if you want to figure that out manually, it's quite tricky to find that. But with things like this, it makes it easy to figure that out. don't know if you've seen it before. I think it's a valid measurement because, I mean, if you ask your neighbor, he probably has another idea of good code than that you have. At least most of my colleagues don't agree with me. So it's always it's a discussion, and some things are really hard to measure. I mean, like I said before, if a null pointer can occur somewhere, that's quite clear. But what do you do, for instance, if the naming conventions of classes or methods or parameters is really bad? People are using x1 and x2 and things like that. Never happened at your projects, of course, but I've seen it sometimes. And yeah, you cannot really let a tool detect that. And also some complex forms or readability, it's really hard for a tool to dive into that. So you can do things like manual code reviews, and lots of people are doing that, but a lot of them use separate tools to do a code review. But the nice thing is SonarQube nowadays, they also have support for doing code reviews. Therefore, I advise you to create a user within SonarQube for every user within your team, so that every user can identify himself uniquely, so that if somebody does a code review and you don't agree with him, you can at least talk to him, else you do not know who it was. And after you have done that, you can easily just say, okay, I want to have manual rules. And if you have manual rules, for instance, with the name code review, then you can click on a line in the code base, and you can say, okay, I want to add a manual issue. And if you have a manual issue, you can just put some text on it and create it. And then, just like the automated issues that are automatically created, you can have manual issues which you created yourself, and you can also assign them to someone or plan them. So that's nicely integrated within SonarQube. Yeah, I mean, you probably all have seen bad design someday in your life. It's quite horrible, but here it's easy to detect that something went wrong. At least I hope you detected it. But in software, sometimes it's a bit more difficult to find it. So what can we do about that? We can create architectural constraints. So that's a mouthful. But what it more or less does is we create a custom rule. Just as there are rules to check, for instance, if a null pointer can occur, we can create a rule that says, the rule is called not from front end to back end, so it already says what it more or less does. If we have like a traditional application with a front end, service, and a back end, we do not want the front end to call the back end directly. We want to call that the front end is calling the service, and the service is calling the back end. So what we do here is we simply say, okay, so all classes that are in the front end package, they are not allowed to use any class in the back end package. And if that rule is effective, you immediately and automatically get these violations in your code. So here it's saying we're in the package front end, and we're clearly using something out of the back end package. So that can help you to make sure that people don't skip layers in your application. Testing, it changed a bit. Before, testing in SonarQube was really easy because SonarQube was tightly coupled to Maven, so more or less the only thing you needed to do was Maven sonar, and your project got analyzed. But now the SonarQube is getting bigger and bigger. Microsoft is being heavily involved, and lots of support for C# and other languages being added. So they're now trying to become language independent, but it means that from a Java perspective now we have to do a bit more. Because Maven and all that stuff isn't longer in the core of SonarQube. So now, instead of this, we need a few extra lines, but you probably put those lines in Jenkins or some other build automation tool anyway, so then you just have to configure it once. The nice thing here is that we can also see what the coverage is per test. I will show you an example in a minute. We have to do a few lines of Maven again, and then we simply analyze the project. We need a bit of configuration. And the cool thing is then, if we have a code base, so we see here a really simple example of code. We can click on the line, so this line, and then we get this. And then it is saying, okay, these tests are covering these lines of code. So then you no longer have to search like, oh, okay, I need to add an extra test, but which test is covering what? You can easily see it from within this interface. And if you click on it, at the bottom they automatically open the test file, so you can see the test file and source file underneath each other, and then quite easily detect what your coverage is doing or what your unit tests are doing. I see a question. Okay, so the question is, can you configure SonarQube that you only measure code where the complexity is higher than a certain amount? By default, I think it's not possible. You could do it manually by, for instance, saying, I know this file has complexity X, or the file's in this package, and I only want to do the coverage analysis for this part, but that's a bit hacky. I don't think it's there by default, as far as I know. Yeah, exactly. Yeah, so you only want to cover tests. You do not want to test getters and setters and stuff like that. But then I think often if your project is structured quite well and you use packages, then most of your difficult code will be in certain packages, but it's always a bit dependent. Another topic quite close to it, integration testing. So you can do both unit test and integration test. And integration test is a bit vague here. So my definition here is it's not unit testing. That's as precise as I can get. Because, for instance, if we want to test this Mario game, we can let the most evolved species just manually test Mario from a GUI. Or we could do a performance test of Mario, or we could test the functionality of Mario. And the same goes for our applications. If I have a web application that's running in Tomcat, then maybe I want to measure the coverage a performance test is doing on my code, or a functional test. I often hear people saying, oh, we have 100% coverage with functional tests. Okay, then run those functional tests, and we measure how much coverage on the code base you have. And then if there's only 50% coverage, maybe you have lots of dead code, or you don't have enough functional tests, or maybe some exceptional flows that you didn't test. But it's really useful to know how much of your code base is actually covered by functional tests. And with this example, you can test almost anything, except some things. And it's actually quite easy. You can add an integration test coverage widget to SonarQube, which I've already shown to you. You download a Yacoco agent. So Yacoco is, some of you probably already use it for doing unit testing and measuring coverage on unit tests. But what we do here is we set a Yacoco agent in the Tomcat configuration. So that way, Tomcat, when it starts up, it is using the agent. And we specify which packages we want to inspect. And we specify which file it has to be written in. And that way, it can automatically measure coverage for any test you're throwing at your running application, which can be quite helpful. One thing to keep in mind here, every time I try this, the destination file or the exec file is only written after you shut down the application server. So I tried it numerous times the first time and I was really puzzled, like, hey, where's my file? But it's only being written after you shut down the server. Yeah. So the question is, if you were doing this on a build server, which is, I think, the most common case, and you have like a test environment where your application is running, how do I get the coverage from the test environment over? They have, I think it's called Yacoco server, which is using something with ports to transfer stuff. And that might work in your company. We tried it within a financial institution where they block every port, and then it's not going to happen. So what we did is just use SSH to transfer the files from within Jenkins, from the test server to our server. It's not as nice, but sometimes in corporate environments, you have to hack around a bit. And then the only thing you more or less need to do is start Tomcat, execute your tests, whatever tests you have. And then you just start a SonarQube analysis where you specify, okay, I already have an IT report path, find my results here, and make sure they're used in the application. And then we can see this. So what we see here is on the left we see the unit test coverage, so all lines are covered with unit tests. And on the right we see the integration test, which is highlighted here. And we see that the integration test is apparently not using the default constructor, it's using only this special constructor. So that way you can easily see the coverage of a unit test and the other tests you're doing. Integration test, I think, is a bit of a overloaded term in this way, but it works. Another nice thing for unit tests, unit tests notoriously have a lot worse quality than production code, at least that's what I often see. Because, yeah, it's not deployed on production, so who cares? You do a refactoring, you don't have time, so you forget the unit test. And it's becoming more messy and messy. And on production code, we use Checkstyle or other checks to check for the code quality. But on unit tests, we don't check anything. I mean, the only thing we check is if the test is running, and if it's not running, we fix it and don't look back. The nice thing is that SonarQube now has also rules for tests. So they can look if your assert includes a message, for instance, or if your assert is logical. To give some examples, this is probably more practical. Here we use assert equals with true. We could also use assert same in this one. Here they say, yeah, you should include a message. Here again, we have some values that can be optimized. So it can help you a bit to at least improve your code quality of your unit test, because that's often lacking behind, and then you get the risk of it getting worse and worse, and in the end, not doing much useful at all. And that's a bit the next topic. Pitest plugin. Who of you know mutation testing? I believe there was a session today, so already some. That's nice. So for me, if you have one thing to take away from this session, listen carefully to this piece, because that's, I think, the most interesting part of the session. So a bit about mutation testing or Pitesting, which is in fact an implementation of mutation testing. We here have a piece of code, really simple. Here we have a unit test, which is an assert, which will be always true. So it doesn't add much value. I mean, whatever I change here, most of the times this will just be true, and it doesn't say anything. This is even worse. There's no assert. So I can change everything here without this test breaking. I mean, if you want a lot of coverage, this is an ideal test. You don't have lots of maintenance work because it will never fall down. Your manager is happy because it's green, you have 80% coverage, but it's crap. I mean, you can't do anything with it. As soon as you start refactoring, you don't know if everything is still working because, in fact, you don't really have tests. It's only a test in name. But yeah, how do we make sure that developers write proper tests? I mean, we could do manual code reviews, but that's quite time-consuming, and probably you miss some things. Or we could do Pitest. And what Pitest is doing, let's go one slide back. So Pitest, what it does is, for instance here, it executes this test, and then if the test is green, which is probably going to happen, then it will change the code here. So it will change the relational operator, or it will change the return values. For instance, if the Boolean is true, it will change it to false, so that a false is thrown back. And then it will execute the same test again. If the test is still green, then it's a worthless test, because I changed my code and the test didn't break. And that way, for every test, the Pitest is making a few different scenarios and testing all those scenarios, and if one of them fails, you will get a violation within SonarQube, and you can see that your test needs some improvement. And you can do that quite easily in combination with SonarQube. You can enable the survive mutant rule, and you can configure Pitest, for instance, with Maven, but I believe you can do it with Gradle or any other build tool as well. And then you just need to supply this, so it's really minimal. And a bit of POM configuration, but this is quite basic. You just have to specify which classes you want to test. Keep in mind, this is time-consuming. I mean, it will generate lots of options for every test and execute all those options. So it can take quite a while, if you have a large code base, to test it with Pitest. So it's maybe something that you want to run during the night and not during every commit. That's up to you. And then quite easily, we can see here, relational operator has been replaced by some other relational operator, and the test still succeeded, so this is an issue. Conditional has been negated, and the return value has been replaced. So it automatically checks the code quality of your unit tests, and that's quite helpful if you ask me, because they're often not as good as you expect. I did this at the company where I currently work, and they were a bit like, it will be okay. So on a Friday afternoon, I tried it on our projects, and we got some code from another team where we built on top of, so we blame them. But still, even if you do it yourself, when you refactor, you make mistakes, you forget to check certain branches. So it's really helpful, because even when I showed the results to the manager, he was not really convinced that, okay, but I have some projects from team members I know they're really good. Can you check them as well? Yeah, fine. I mean, it's automated. I just put it on and I'll see what the results are. And indeed, they were a little bit better, but like 10–20% maybe. So still quite a lot of issues in there. So you might be surprised what you get out of the results. Other languages, I quickly already mentioned it. It's no longer just Java what's been doing by SonarQube, but more or less everything. So if you have a Java project nowadays, it's often not only Java, but also JavaScript, unfortunately. So you can also just do automated JavaScript tests. I won't explain them all, you can read them as well. It's more or less the same as for your Java code, but then specifically for JavaScript. The same goes for CSS. Sometimes CSS becomes quite ugly as well, and nobody really cares until something breaks and you have to spend a lot of time doing CSS, and it's not my hobby, so maybe it's your hobby, but I would make it as simple as possible to make sure that if you have to add something, then it's quite easy. And you could do the same for HTML files, so that's some basic checks are included. And the nice thing is, this is introduced, I think, in the latest version. So what if you have a project with Java files, JavaScript files, but you also have READMEs in every package with a description of what the package is doing, and you want to see that within SonarQube, because else you first have to go to your IDE or to Git or whatever. With this feature, import unknown files, it just imports every text file that's in your repository. So text files and everything, it's just included within SonarQube. So if you browse through the code in SonarQube, such as for instance here, we can see this is just a text file and it will just display the text. Then you can say, okay, I never look at it anyway, or who does READMEs anyway? But the nice thing is, you can also do manual code reviews on this. So if the documentation is for whatever reason not up to date, you can make a manual code review of it, and then it's visible for everyone that that still needs to be updated. So that's quite a nice feature, I think. Some leftovers. So if you do Sonar, and you have multiple versions of the same project, you probably want to have separate projects within SonarQube. And that's quite easy. You can just specify the different branches. Difficulty is if you have like false positives or other project-specific settings within your project, then they are not included if you make a branch. So if I have like flagged 100 things as false positive, and I create a new branch with the property at the top, then I again have those 100 issues that I have to flag as a false positive. So if you have lots of false positives, this is quite annoying. Exclusions, you can exclude whatever you want on source level or on test level. So you can specify, if you have lots of generated classes, you can just say, okay, this directory contains my generated classes. Do not analyze them, I don't care. You can also, if you look in a file, you see some basic statistics like lines and stuff like that, but you can click through it and see like everything of it. And this is more or less a public view of the database of SonarQube, where you can, for instance, see all the data from Pitest from the mutation analysis. So if you really want in-depth data, then that can help you a lot. Next to that, we have duplications across projects. So sometimes you have duplications within your project, and yeah, you refactor them. But what you sometimes also see is, okay, that project did something which is really nice. I just copy-paste it, put it in my program, and then I have the nice stuff as well. But I mean, that's a maintenance nightmare. It would be a lot better if somebody would just create a library or something of it, which you then can include with Maven or whatever as a dependency, because else you have to maintain the code in all kinds of different places. And with this setting, you can simply check if code is being used across projects. So it basically compares every project with each other. It is not enabled by default because it will take some time to compare every project with each other. So it's based on if you really need it. It can be helpful. So for instance, here we are in the Docker Py project, and we say that there is a duplication in the test application, and we can see which lines it are. So then we can easily pinpoint, like, okay, you have exactly the same code, so probably you have been copy-pasting. Technical depth pyramids to see, like, oh, in which area are the most issues that I have. We'll also do it quite well with management, these nice graphs. SCM activity, so before it was a plugin with which you could see who adjusted the line last. So what happens if I check something in Git and I'm the last one that changed this line, then Git knows, okay, Johan is the last one that touched it. So SonarQube will also display, okay, Johan was the last one that changed the line. And then you say, who cares? I mean, it's nice that you submitted that line, but okay. But what if I'm reading through the code and I find an issue or something that's unclear to me, and I would like to speak to the last one that worked on it? Then you could use this quite easily, because the name is already next to it, and if you have a larger team, that's really helpful. And you can just walk to the person and say, okay, I have a question for you. Always name it a question. Don't start blaming immediately, because this only shows the last person that touched the line. So if somebody just did formatting, he was the last one that touched the line. Maybe he didn't even introduce the bug. So always start with a question and not blaming. Web Service API, so if you want to go full-fledged and are like, okay, SonarQube is nice, but I want more, then you can even use the Web Service API or the plugin infrastructure, because SonarQube is really easy extendable, so you can add extra things that you want to it through the plugins. That's really nice, and SonarQube itself is also open source, so you could probably also adjust that one. Lately, they really separated the access to the database from the application. So now more or less everything happens within the application and is later pushed through the database. So you don't need a constant connection to the database anymore. And they can have some nice extra metrics. For instance, they can say how long it took to analyze a project and watch the log files, for instance. So we can see, okay, how long did it take to execute the different steps? Of course, probably if you attach it to Jenkins, you can see the same stuff in Jenkins as well, but now it's all within one application and easily visible. Update Center, so if you're a really older user of SonarQube, installing plugins in SonarQube was like dropping a jar file within the plugins directory, and then you had a new plugin. Nowadays, it's luckily a bit better. They have a complete update center where you can just say, okay, I want to update this plugin, I want to install that new plugin, and then SonarQube will handle the rest for you. So that's a lot easier nowadays. So I often hear, okay, SonarQube is really nice if I start a new project, because then I can keep up the quality at a good level. But we are in a crappy project which is already running for years, and it looks a bit like this. I cannot do SonarQube in it. It's not worth the effort. But actually, you can do some things then. You can, for instance, do these things. I will go into some of them after this slide. For instance, you can look at the hotspots. And hotspots, again, it's a widget. So I created this dashboard, and I wanted to see what are the biggest classes or files what are the most duplicated lines or files that contain duplicated lines, the files with the highest complexity, and the files with the most issues in it. That way you can easily see, okay, if a class pops up as the class with the most issues, with the highest complexity, probably it would be a good area to invest in and try and improve that one. So that way you can easily try and incrementally improve your code base, starting with the worst parts of your code base. Another idea is, if you have lots of issues, you could also start planning those issues. And therefore you can use administration and an action plans. And then there's actually, you can create as much of them as you want. So an action plan is like a bucket full of issues. So you can, for instance, say, okay, release 1.0 is coming up. I want to fix a certain amount of issues in that release. So I create a bucket for it so I can easily monitor if almost everything is done by the time we're doing the release. And that's, again, really easy. You can just click on an issue and say, oh, I want to plan it. I think you can even bulk change it. And then you can see, okay, it's planned in release 1.0. So it's sort of a planning mechanism. And you can even query for it. So you can query all your issues to see which issues it has. Some short tips if you use SonarQube within an existing project or maybe in any project. What helped us a lot was to create issues or stories on our backlog to work on improving the code base, like spend every sprint a day on it or whatever. But then you at least make sure that it's keeping improving instead of staying stable, or most of the time it goes down. Really perform manual code reviews. As advanced SonarQube is, you still need manual code reviews to make readable code, because that's, I think, one of the most important aspects. And if you have items, either fix them or mark them as false positive. Some items SonarQube detects are false positives. Okay, then just mark them as a false positive so they don't show up anymore. And use the separate logins, mainly to use when you do code reviews, because else you cannot see who did the code review. The settings reviews are project specific, as I already mentioned, so if you do a lot with branches, it's really difficult. And if you use SonarQube within a project, I really advise not to only run it on the build server, but also run it on your own machine, so you can check the code quality before you push it to your version control system. And nowadays, SonarQube has something they call SonarLint, which you can install as a plugin within your IDE, Eclipse, IntelliJ, and then it checks your code on the fly for issues. So you don't have to say, scan my code. No, it will continuously check while you're typing if you introduced any issues. That way you can quickly resolve issues before you commit it to the build server, and your colleagues can see how crappy the code was that you wrote. Only disadvantage there now is you can only use it with the default profile SonarQube is supplying. So if you want to have manual checks, that's not possible at the moment, but they will probably include that in the near future. And always take code quality as one of the things that you check. I mean, lots of teams, they check if a change is functionally doing what it should do, but also check if the code quality is of the level that you agreed within your team. Because else you end up with things like these. And here we say, okay, this shouldn't happen, and why did those idiots do it? But when looking at code, I often see the exact same issue appearing again and again, because it's either not checked or developers don't act upon it. And I think we can improve a lot by making ourselves better as a developer by just taking it into account and learning from others and tools that say what we are doing wrong. So really accept that you sometimes do something that's not good, but at least fix it. Questions after all these different topics? Yeah. Okay, so the question is, if you have 4 projects, would you run it on one instance or on multiple instances? Funny thing is, in the beginning of SonarQube, there was a question from someone that said, SonarQube is really slow. And then they asked, how is that possible? Yeah, I think he had 10 or 20,000 projects in one instance. And it was slow, and I think the next release, they already fixed it, so it was workable with that amount of projects. And I have seen it easily with tens, maybe even hundreds of projects. It still works quite well. So with 5, it should work perfectly, or the code base should be really big. But other questions?
don't think SonarQube supports multiple inheritance.
Yeah, so the question is, what do you do with profiles and inheritance? I think you're right, and multiple inheritance isn't supported. But normally what we do is, most companies simply have only one profile because they didn't even bother to look at the details. At least that's what I see in my work. So what we mostly do is we just extend from that profile, so we can say to management, like, we have those checks, but we have added some to it, and we inherited this, the standard set and added upon it. And then most of the time management is, oh, okay, you want to do something extra, it's perfectly fine. So that's the way we handle it. Does that answer your question?
Yeah, basically. But also, when you update your SonarQube instance, you get newer rules with the new built-in profiles. So I think you have to explicitly reset the built-in profile to get the new rules. That's a bit cumbersome.
Yeah.
You get a lot of new violations every time you do it that way.
Yeah, so the question is, yeah, okay, if you do an update and you get new rules and then projects suddenly start getting new issues, that's something you really need to manage because people will get really annoyed with that, especially teams that are having a lot of issues already. I mean, if you're upfront and trying to improve, then mostly you have, oh, okay, I fix those extra issues, but people that are lagging behind, it's quite an issue. And that, yeah, there's not really a solution for that, I'm afraid. You have to manage that and keep track of the rules. I think that's the easiest way. But I think once you have created a separate profile yourself, then the rules won't be overwritten by default. So if you want to make sure that the rules stay the same, create a separate profile that doesn't inherit or something like that, and then I think it should stay the same even if you update.
Yeah, it will stay the same if you don't get the new rules. And if you automatically include the new rules, your quality gate will be red. And yeah, even though the code quality is better.
Yeah, it's a trade-off. Yeah, you can either automatically get new rules and get people complaining, or you keep the old rules and you have other people that are complaining. It's, yeah.
Okay, we can take one last question.
Question about the mutation testing there. Is it only applicable for JUnit tests, or can you do it on like Cucumber tests as well?
On a Cucumber test doing the Pitest stuff, I don't know. I know it's used for Java and some other languages. For Cucumber, Cucumber Underwater uses Java as well, isn't it? So you should be able to do it, I guess, but I didn't try it.
Okay, we take the last question.
Yeah, just a small question related with this review board. For example, if I, as a developer, committed a piece of source code and the reviewers from the SonarQube, they rejected my piece of source code, said something is wrong in it, will that part of source code will be reverted in the code version system as well?
No, but if I understand the question correctly, okay, if SonarQube detects an issue in your code, will it automatically revert the code? Or?
Yeah, revert the code in the code version system.
Yeah, no, by default it isn't doing that. Then you could do it, I think, with other tools like, I think Garrett is for code reviewing. There you can automate some things with branching, but SonarQube isn't supporting that out of the box at the moment. Then you have to use some tooling around it. So normally it just accepts the code, and then you either have to fix it or revert it manually yourself. All right, thank you all.